Good morning. I'm Karl-Heinz Stawiarski. I'm Managing Director of the Federal Association Heat Pump. And today I want to tell you something about some innovative large-scale projects with heat pumps and today's state of the art. This is my agenda. I want to show you how we have grown in Germany, what we mean by large-scale projects, what is special about heat sources and where they can be used and how, and then I want to show you some reference stations. Classical heat pump systems in Germany, as in other countries, the heat pump is grown with earth-coupled systems for a start, because if you're newly interested in the technology, you have much more confidence in earth-based systems than in air-based systems. You can see it here to the left-hand side. There are these borehole heat exchangers or wells, and we also have flood collectors in the earth, and their energy is taken from such areas. In classical one-family dwellings, the heat exchanger will be drilled down to 100 meters in the earth, and if there is special demand, 2 or 3 heat exchangers are drilled next to each other. That is special for one-family dwelling. Taking a look at the development throughout the years in Germany, then we went into the marketing of heat pumps quite intensively 50 years ago in Germany, and by now the market shares have changed strongly towards air-based systems. And here you can see a compact system which is positioned outside. The same is possible inside as a compact machine, everything in one housing. And something we see more and more recently is due to Japanese and Chinese influence, the so-called split equipment with an internal unit and an external unit. That is the situation for one-family dwellings in Germany. In large-scale projects, it is a little bit different, and this is what I want to discuss with you briefly. Air, in classical terms, according to German design of heat pumps, well, we are not that much at home in large-scale business, because the way in which German manufacturers build air-based machines in one casing, they are not machines which are big enough, which we need for such kind of application. When talking about large heat pumps, we talk about 100 kilowatt and more. As a standard, the German manufacturers provide up to 40 kW, and then you would have to scale up. So in large-scale applications, these heat pumps have not yet made their way. This looks different in Japan and China. There are so-called systems based on VRF and VFV, and thus they can place several units on the roofs outside. If we take a look at heat exchangers in industrial and trade application, then we start from a normal construction depth of 100 meters and move away from there, because there are heat exchangers down to 500 meters. Normally they are drilled down to 200, 250 meters, because in many industrial applications, the cooling effect of the earth shall also be used in summer. If the heat exchangers are drilled too deep, you don't have the effect anymore, because the temperature becomes too high. Therefore, such large or deep heat exchangers are used, because you can save space, because you have one big deep drilling, not several you have to combine with one another, and the temperature level increases the further you go down. Every 30 millimeters by 1 degree, and this is exploited here. And the classical heat exchanger, which we use in one-family dwelling, doesn't have the same output as a heat exchanger, which goes down to 350 or 500 meters into the ground. In the industrial application, the groundwater is exploited. This pays not too much in one-family dwellings, because it is very intensive in terms of research to know whether the groundwater is apt for the application of heat pumps, whether it's available on the right level and in the right composition. Hence, if there are harmful parameters like manganese, iron, thermal conductivity, this is kind of attractive to use groundwater in one-family dwellings. Then you really need to do water analyses before, and of course, this pays much more in industrial application. Here you can see one example, the town hall of Zurich, older than 50 years. There even surface water was used to operate a heat pump. Surface water means rivers, lakes, and on the North Sea coast, even the sea for water. Here the temperature in the surface water is not that deep as in groundwater areas, and this reaches frost conditions easily in winter times, and then you would combine with conventional systems to be operable. Then, in the course of the years, we have developed the knowledge according to which the wastewater we have in the ground reaches quite high temperatures, and since the heat pump is kind of a low temperature heating system also on the source side, can use these temperatures in an ideal way. Hence we extract heat from the wastewater. You see it here in the big pipe. In the sheath, it has heat exchanger pipes where the energy can be extracted, and from there you can plug directly into the heat pump on the heat source side. Something more recent, which makes it sway in Germany, is the so-called ice storage. Here you see a very large model. You see the person standing in it. This can produce more than 2 million liters of water to be stored there, but it's also available in a small variant for one-family dwellings. Then we move in the order of magnitude of the garage, which is placed in the ground. But there are no limits in terms of size, basically speaking. Large heat pumps, what does that mean? Well, in Germany, if we take a look at the market development, then this means one-family dwelling applications with building sizes of 6, 8, 10 kilowatts, depending on the insulation situation, and then there are some minor industrial applications. But large heat pumps start from 100 kW, and then they may range up to 2 megawatt, with a big difference being to the daily business that such business can not be sold off the cuff or in a ready-made fashion, but it needs to be tailored to the individual situation. In office applications and in large-scale applications, as indicated here in the facade, you see the energy gain we get because there's more cooling output than heating output in buildings, because there's external gain, there's the waste heat produced by all the people working there, there's computer waste heat, hence heating in an industrial situation is not an art, really, and it makes sense to discharge the heat which is there in an excessive way, and this can be done intelligently by using the excess energy to cooler areas in summer, which you would harvest in winter, on the other hand. Cooling is a topic anyway, and we have dealt with it strongly. Formerly there was only talk of ordinary heating, but since we have great heat insulation in our buildings, we have window insulation, therefore we also have heat gains in the house, and we have to discharge the heat from the houses. Hence well-insulated one-family dwellings are quite demanding in terms of getting good room climate. And well, the heat needed is no longer the guiding factor. It is different in existing stock of building where we still need a lot of heat. Therefore, the bivalence, we know this is known in the heating business, hence you don't get to a corresponding temperature level, therefore you combine two technologies, normally a heat pump and a boiler, or in the upper range, you do it conventionally to take the heat pump to 100% in terms of design, which makes the station quite expensive and large. So the solution is a bivalence or a hybrid station, meaning that 90% are covered by the heat pump and the rest in a peak situation is added on top, which means that you can avoid this intensive situation. Before, there was talk of bivalence, hence two systems supporting each other. Nowadays, we use the notion of hybrid stations, which you can also find here in the form of compact machines. These we still have these two machine generations, and the control unit is put on top of it, and then the station can also see which energy source is more economical, be it the gas side or the electric power side. And today's hybrid stations can control that itself. Here an example from 1 and 2 family dwellings. Here an earth collector was installed in complete agricultural regions. 4, 5, 10,000 square meters were equipped with collectors underground, and this heat was made available. In Holland, for example, you can heat large greenhouses. There are also local networks with the heat pump as the central element of the entire heat unit. And so it's not deeply digged heat exchangers, but extraction pipes put at a depth of 1.50 meters on a large surface. Then settling plays a role. In this example, we talk about cold local heat. Here, the heat source side is made available by the local government. The local government would drill a well, and then pipes are built throughout the community, and everyone can connect to the system, which is very economical nowadays because you have a very clean heat source. And if this is directly planned by the local government, it's quite comfortable for the customers to get the respective prices from the heat supplier. Here an example of multi-story houses. The heat pump is not only available for one-family dwellings, but also for multi-story dwellings with a heat output of 340 kilowatt. In this example, there are several heat pumps juxtaposed to one another, and there is a heated surface of 10,200 square meters. Hence, architects who use this concept. This is a French concept called Le Salle. In Düsseldorf, there's the energy central built according to ecological concepts, and the entire building, of course, is subject to special management. In Hagen, North Rhine-Westphalia, an entire suburb has been reconstructed with several office buildings which have been rehabilitated, and in sum total 94 heat exchangers were equipped in a depth of 92 meters, hence a gigantic construction site which was finalized last year. Therefore, I do not yet have the consumption values. But with the examples of the buildings, there is a seasonal performance factor of 4, which is achieved throughout the year, and thus you can write black figures quickly. Here, another project from Bavaria, the town hall in Fürth. Through a subsidization program, this was rehabilitated with a large heat pump and a boiler using gas. The special thing in this model is that wastewater temperature is also used, but as compared to the example we saw before, with the duct itself functioning as a heat exchanger, here 80 meters of high-grade steel plates were placed, and thus the heat is extracted from the duct which was placed in front of the town hall. And this model has made its way in Bavaria. It has even been awarded prizes, and it's being copied by other local governments and municipalities. And we've already heard about the model function of the public sector for that matter. And you can see in this example that rehabilitation is feasible, and in large public buildings we can use heat pumps in a meaningful way. In Augsburg we have equipped a football stadium, soccer stadium with a heat pump. If clubs are playing in the Bundesliga or First Division, you need to guarantee to the FIFA that matches can be played each and every Saturday because of TV rights in any weather. Before it was done with oil heating, but you cannot do it in an ad hoc fashion at high temperature, and therefore the preparation needed 10,000 liters of fuel throughout the week, whilst nowadays it is done with a groundwater heat pump, which is not always running actively, but the groundwater is only running through the station, and the temperature level of 8 to 10 degrees is enough for dewing effects. Hence, a model which has a great model function, and we hope that this will be copied throughout the world. Here you see a combination, which is the talk of the town. This is photovoltaics and heat pump, hence self-generated power put into one's own station, hence you wouldn't put it into the grid selling the power, but you would be independent and sell it yourself. And the big side effect is if you take a heat pump with 75% environmental type energy being absorbed in photovoltaics on the heat source side, you get a CO2 neutral heating system. Hence, what we all are aiming at is being built there. And this is what our future will look like. That is the so-called heat pump city. That is the symbolized here. Heat pump city. You see the multi-story building, the original building supplied with a heat pump by using water. You see new one-family dwellings at the front, for which heat exchangers and wells are used in the front field. The river flowing through the town also represents heat extraction, the so-called surface water. And there are subway ducts where we can use waste water to be put into the heat pump. To the right-hand side, you see this ice storage, which we can use artificially. So on the one hand, we use the new buildings, we have the old buildings, we have the high-rise buildings and the hotels, and we also have industrial zones in the rear of the picture. So as of tomorrow, you could heat with a heat pump CO2 free by using all these facilities, including wind energy and photovoltaics, in order to operate these heat pumps. Some reference stations, well, here major project from Bavaria, the Ganghofer Siedlung, which has been rehabilitated based on a stock of old buildings. 131 family dwelling owners were convinced to take part in a joint project, and all of that was rehabilitated with the use of heat pumps, and 30,000 meters were drilled with 44 heat exchangers and a saving per house of 3,700 kilowatts CO2 as compared to the past, when old oil-based heaters were used. And here a model was placed which, from the planning to its realization, really represents a model's role. And of course, 130 people being involved had to be convinced of one philosophy, which of course is quite a big job because people didn't know that before. As mentioned before, another example, Troisdorf, with a residential area with almost 100 houses being newly built. And in this newly developed zone, water pipes were placed, supplied by well, and if the water pipe is placed in front of your house, it is very easy to connect a heat pump and let it run. The supply is taken over by the municipality, and the Mosselfeld is now in realization. Half of the station has already been built, and by the end of the year, the second building phase shall be completed. The results achieved have been great, and the last reservations of the inhabitants have been done away with when they moved in. Here another example of our member from Switzerland. In Seoul, they built a house with a height of 660 meters, and they equipped it with heat pumps, 6 brine water, 6 water heat pumps, and a heat output of 22 MW, respectively 20 megawatt cold output. If you consider the entire drilled meters over this distance, well, this lives up to the classical efficiency, and wherever possible, given the know-how, heat pumps are used. Here's something quite large in German understanding, the Henninger Turm, 140 meters high, newly built, based on the classical model, then completely equipped with heat pumps. We have 40 stories, 207 apartments, and a heat output of almost 400 kilowatt, and it shall be finalized in 2016 altogether. We are screening such projects, and if this will be finalized by 2016, it will certainly be interesting to take a look at the entire project together with you. One of the best-known large projects in Germany is the school campus in Duisburg, North Rhine-Westphalia. 21,600 board meters were developed, and before in one-family dwelling applications where this was used, and then 180 heat exchangers of 120 meters shall be realized. This means quite something in terms of protection. And up to now, we didn't have so many planners in Germany dedicating themselves to this kind of technology, because we have grown up in one-family dwelling developments. Manufacturers and craftspeople cooperated together with the planners in these minor scales where the planners didn't play that major role, and therefore we still have a lot of pent-up demand to realize such projects in this order of magnitude. 2 further examples of churches. Churches are mostly old buildings, and they need rehabilitation and reconstruction. And with a heat pump, you may save a lot of costs, but since we only need to heat during 2 services on Sunday, we need to start heating the walls in the middle of the week, and therefore this is also quite ambitious in terms of control. Then heat pumps are also used in spa facilities and hospitals, and there the entire balance of the CO2 footprint is in the foreground. In industry, we want to realize the LEED certification to reach silver and gold standard. So you need to plan and project with the heat pumps to have low ancillary costs. Here, IKEA can not only build cheap shelves in one-family dwellings, but they can also use major technology, like in Berlin, to extract energy. And at the time when they constructed this building, they only did heat pump-based heating. And now IKEA wants to continue this project European-wide. Here you see the savings potential, the heat output, 1,500 kW, the factor of 105, seasonal performance factor, because we have enormous temperatures in wastewater which can exploit. Here the ice storage, which I showed you before. Here, taking the big ice storage of Ecolab, this would be enough to put inside our big group 4 times, 3 times on top of each other, to give you a feel of the size of such a station. In the final phase, the entire body would be filled with PE lines, and this is the source extracting the energy from the earth and providing the output. We have an entire output of 720 kW and a water volume of 1,800,000 liters being accommodated in the ice storage facility. So that's what I wanted to show you as examples, and we are also partnered to the GIA, and we have also launched our own campaign, heating in green areas. We want to use the energy label advantages of the heat pump, the value added with renewable energy, and from the Federal Association Heat Pump you can get informed about the advantages of heat pumps for heating, but also for cooling. Thank you for your attention, and if you have questions, I'm now available to answer them. Thank you very much.